Okay, if we look at example 2, use the intermediate value theorem to show that the equation y equals the square root of 6 minus x minus 4.5 has a root on the interval negative 15 to negative 14. So, once again, we're looking at a function here. Okay, this time it's a root function, right? It's also a polynomial because it's got minus 4.5. So it's both those types of functions. Root functions aren't all real numbers. So what we have to do for a root function, we take the radicand, set it greater than or equal to 0. Okay, so there's sometimes a little bit of work involved in finding the domain. I do this before I start writing out my 1, 2, 3, and 4. All right? But again, anytime I see a radical, that's how I find the domain of a radical. Whatever's underneath is greater than or equal to 0, as long as it's an even radical. It's not, it's all real numbers. It's a cube root or a fifth root or a seventh root, it's all real numbers. But even roots, the radicand has to be positive. So 6 minus x is greater than or equal to 0, which means negative x is greater than or equal to negative 6. We don't want negative x, we want positive x. Requires me to make this positive 6, and the requirement in an inequality when you change signs is the inequality has to flip direction. X less than or equal to 6. As long as I pick a number less than or equal to 6, I'll be taking the square root of 0 or a positive number. If we test it out, if I put 6 in, what's 6 minus 6? Square root of 0 is 0, that can be done, right? If I go less than 6, like 5, what's 6 minus 5?
Negative.
6 minus 5 is 1, positive, square root of 1 is possible, right? So numbers that are less than 6 or equal to 6 make this possible. That's what we're trying to do with domain. What values of x can we put into this function so that we're going to get something out? Legal, not imaginary. If I went against this, let's say I pick something bigger than 6, 7, 6 minus 7 is negative 1, all of a sudden we're in the imaginary number world. Okay? We don't want to deal with imaginary numbers in calculus. We like real numbers, so we're going to stick with that domain. So, step 1. The domain is x less than or equal to 6. Look at our interval, negative 15 and negative 14. Is there anybody in here who thinks that negative 15 and negative 14, all the numbers between these, along with those two numbers, is there anybody here who does not believe that those numbers are less than or equal to 6? Okay, absolutely good. That's good. If you did, we'd have to have a discussion about why you're in this class, because that would be bad. Anyway, 6 is here, negative 15, 14 are there, we're going that way, right? So these numbers, all these numbers are less than 6. So we can say and negative 15 to negative 14 is a subset of x less than or equal to 6. You could have also gone with the interval notation negative infinity comma negative 6. You can establish a domain in interval notation or inequality notation. I'll take either one. But the domain is all the numbers between negative infinity and negative 6, or positive 6, and this is a subset of that, or the inequality version. Okay. All subset means is that it contains it. It's contained inside of it. So negative 15 to 14 is all within less than or equal to 6. Step 2. F of x equals square root of 6 minus x minus 4.5 is a root and polynomial function. Root and polynomial function. So the root part is the square root of 6 minus x. The polynomial is the minus 4.5. If it had plus 6 sine of x, it would also be a trigonometric function. If it also had 6 over x, it would also be a rational function. So it could be a combination of these functions. The domain's a little bit more involved if it was a rational function. But the point is, every piece in this expression is a type of function. That's a root, that's a polynomial. So make sure you name all the types of functions it is. Step 3. I want to evaluate f of negative 15 and f of negative 14. Now you can see that this will be a little bit more involved than the last one, because cubing 1 and negative 2 is easy. Taking the square root of 21 and 20 is not going to be as easy, right? So what I want to do is I go to my calculator. For some reason I shut down earlier. Open it back up. That's a pretty good video. Waiting for the calculator to open. There we go. All right. Go to y equals. My function was the square root of 6 minus x minus 4.5. Always make sure that you got the square root, hit to the right to get out of the radical. Make sure you type the thing in right. If I just type in my calculator the function, and I type in these numbers, negative 15 and negative 14, it'll evaluate it at those two numbers. And we get positive 0.08 and negative 0.03. As far as rounding is concerned, go a couple decimal places. The whole idea is I don't care so much about the numbers as I care about the signs on the numbers. This one's positive, this one's negative. All right, that's the requirement. In order for the intermediate value theorem to work, we have to have one positive, one negative. We have that. So step 4, every time step 4 is the same, by IVT, f of x has at least one root on the interval negative 15 and negative 14. I think there's a problem in your homework where the sign doesn't change, or one of the endpoints itself is 0. All right? If that happens, just scoot in a little bit. So what I mean is this. If this came out positive, this also came out positive, then pick negative 14.5. Okay? If there's an answer between negative 14.5 and negative 14, there must be an answer between negative 15 and negative 14. All right? So what I'm saying here, just to give you a visual, so I'm not talking in the air. Let's say that this, here's A, here's B, all right? And we want to make sure there's an answer between A and B, right? And let's say A comes out positive and B also comes out positive. There's nothing preventing it from doing this. It could do that and still hit a root, right? So what I'm saying, though, is if you were to pick, let's go back there. Let's say I pick some number in between A and B, let's call it C, and we find out that f of C is negative, all right? What that proves to me, if f of C is negative, f of B is positive, there's a root between C and B, right? If there's a root between C and B lives inside of AB, then A and B must also have a root. All right? So in other words, if you don't get this opposite sign thing happening on the third step, scoot in a little bit. Just pick a different number in between those. Hopefully you get a different sign at that point. Once you get one positive, one negative, there's a root in that interval, which allows you to say the bigger interval also has a root. I seem to remember one homework problem that happens where you don't get the sign change to occur. Just pick a number in between and keep going until you find one where the sign change occurs.